Hi friend, this is Shoumik Bishwash. My today's topic is Laplace transformation. So that is Laplace transformation. So Laplace transformation is a tool. So what is the objective of this tool? This tool turn ft into f j omega, means fs, provided that ft should be continuous function with element of t. So that j omega is called complex time domain complex frequency domain, and that t is time domain. So time domain to complex frequency domain, this transfer is done by this tool Laplace transformation. So in that circuit theory, we should first come to know about this application of this. So how can I write that f of s, if it is a Laplace transform of a particular continuous time domain signal ft, so it can be written as L of ft, that is equals to integration of 0 to infinity f of t e to the power minus st dt. Okay, now that ft is our subject of interest. Now as per the Laplace domain, as per the Laplace transformation system, so on this today's class, actually the Laplace transformation we may having consecutive few lectures which will tell, number one, that simple Laplace transformation and inverse Laplace. In that second section we will have some pulse train. It means some given ft function which will be given in terms of pulse train. We have to find out that fs from this, and then we have to represent the entire system in the form of ft. The third one is solving differential equation. So in this differential equation section, what is the form will be given? Suppose, say for example, it is given d2y by dt square plus k dy dt plus p equals to e, suppose. Okay, so how to solve this? We have to use Laplace on that. If you are writing in that form of Laplace time domain equation, so it should be d dt in this way, y equals to f of t plus k d of dt f of t. Here as you can see that p here is given of ut, that e given of ut, so that is unit step function. Now these are the three main important domain on which we will discuss the Laplace transformation. So first of all, on today's class, what is a Laplace transformation and what is the inverse Laplace transformation? First we will discuss this topic. So let us having some symbol or that given predefined signal as ft equals to, number one, how many signal you have taught, that is first of ut, that is unit step function. Okay. So if you are using that ut unit step function against this ft, so what will be fs then? Fs equals to integration of 0 to infinity ut e to the power minus st dt. Here ut equals to 1 actually, so it should be e to the power minus st by s if you are integrating this. So obviously the limit is 0 to infinity, and obviously e to the power 0 means 1, so it is infinity means that is 0, so it should be 1 by s. Number 1. Number 2, ft equals to kt, that is called the ramp function. So what will be the output then? That is kt, so you should write that integration of 0 to infinity k outside t e to the power minus st dt. If you are taking by parts of that, it should be 1 by a square into k. Okay, so actually the t power here is just doubled. So if we are getting a Laplace transformation of kt to the power n, so it should be k s n plus 1. Okay, now number 3, if it is some sort of exponent function, so ft equals to e to the power minus at, suppose. So what is the output? E to the power minus at e to the power minus st dt, integration of 0 to infinity. So it should be 1 by s plus a. If you are taking that different, ft equals to e to the power at only, so it will be giving 1 by s minus a, because quite same type of problem. Okay, now number 5, ft equals to a sine of omega t. How to do this? A sine omega t, you can write it as a e to the power j omega t e to the power minus j omega t, because e to the power j omega t means what? Cos and sine. Here it is cos minus sine, so if you are subtracting them, so that minus will be coming as by 2j. Okay, so that minus will be coming. Okay, so it should be, first of all, if you are taking minus common, so you should write this is minus, this is plus. Anyway, so if you are Laplace transforming them, so obviously that a by 2j will be coming outside, and this is minus j omega, so this particular term can be replaced with that a, so it is 1 by s minus, so it should be s plus j omega minus 1 by s minus j omega, so it should be minus minus, all two should be cancelled out, and that is minus, and that is, sorry, 1 minus will be here coming out as, and this is plus, so it should be, that is j omega, so it should be a omega divided by a square plus omega square. Okay, so in this way, yeah, one thing I forgot to mention to say that in this particular one, kt to the power n, it should be 1 factorial n, which I have omitted to write. So finally the equation for t to the power n is like this, factorial n by s to the power n plus 1. Okay, so here number 6. Now if it is some cos function is given, so suppose example ft equals to cos of omega t, so you should break this function in this way, that e to the power j omega t plus e to the power minus j omega t divided by 2, so it should be putting in this type of equation, so finally it will be coming as it's coming as s by a square plus omega square. Okay, so now okay, one more thing, that is a shifting function. I should mention like this, say f of t equals to e to the power at cos omega t. So what will be the output? Need not do any sort of calculation, just transfer that s up to s plus a, because we know that if it is s plus a, for it to be minus at, so it should be s by s plus a whole square plus omega square. Okay, now number 8, if ft equals to delta t, so the Laplace will be 1. Okay, now here 9, what is 9? That one more function, that u t minus a, suppose if it is given as a shifted unit step function, just like this. The equation is like this, this is a and like this, so it is a unit step function. So the Laplace of it, what should I write? That u t minus a e to the power s t minus a dt. Okay, now if you are integrating them 0 to infinity, it is giving you result that e to the power minus as outside, inside that is 0 to infinity u t minus a, that is e to the power st dt. So it is 1 basically, so it is 1 by s, so it should be e to the power minus as by s. Okay, okay, so these things are the very few things but very important when you are doing the Laplace transformation. This 9 formula you have to just memorizing yourself. Okay, so I am coming to the next topic, which is called that inverse Laplace transformation. Okay, before going to this inverse Laplace transformation, I have to say something, that what is, you can mind it as number 10, that is a rule of derivative. If we are doing Laplace of ddt of ft, so what will be the answer? It should be sfs minus f0 plus. Okay, now if you are taking limit of this, so if here limit sfs as s tending to infinity, so what will be the probable value? Then only it should be f0 plus for limit t tends to 0 plus. So it is a limiting value. So this is called the this particular equation, you can see that is the prime formula for this particular one, and this is called that initial value theorem, and the reverse of it is called the final value theorem. The reverse is just like, so if that limit sfs for if s tends to 0, it should be that limit ft that t tends to infinity. Okay, so that is the prime factor to say. And another thing that we might discuss, so that is a rule of integration. So in the case of rule of integration, so we have some particular line to follow. It is very easy to understand that if you are integrating that L of integration of ft having an integration inside dt, so here it should be not sfs, rather fs by s plus f0 plus by s, that is the initial value for that function at t equals to 0 plus. Suppose one capacitor is using in a particular circuit, so before the circuit is on, the capacitor should have the initial charges, so it is F0 plus. If nothing charges rested inside the capacitor, so no prior or predefined value is there, so obviously F0 plus will be 0. Now what is the inverse Laplace? Say suppose one question is given as question number 1, say Fs equals to 1 by s plus 2. So what is Ft? What is Ft? So it is s plus 2, you can say it is a, so it should be e to the power minus a t. If you are doing this, so it will be coming to that 1 by s plus a, so it should be 2. So the function is obviously e to the power minus 2t, like this. So in this way, suppose one question is given that Fs equals to s by s plus omega s square plus omega square in this way. So what is the final output? How to do this? So to solve this, you have to do some by parts, because this is a s plus j omega plus b s minus j omega. So if you are comparing this, so it should be here, if you are putting this 1, this is 1, so it is 2s. So if you are taking half, you can write that 1 by s plus j omega minus 1 by s minus j omega, right? So it should be half e to the power j omega t minus e to the power plus here e to the power minus j omega t, and if you are taking Laplace of this, so finally it should be cos of omega t, like this. Now suppose another problem is given that Fs equals to 1 by s plus 2 into 1 by s plus 3. So what should be Ft? That is, again we are doing a by s plus 2 plus b by s plus 3. We are taking Laplace of this, so that is as plus bs, okay, plus 2b and 3a. If you are taking coefficient of each side, that s a plus b equals to 0, this term, so s into 0, so a plus b equals to 0, so a plus b equals to 0 and 2a plus 3b equals to 1. So just equate them up, this one, and you'll be getting the value a and b, putting up there, and it is simple, say e to the power minus 2t of that particular constant, say something xk, and plus for this what will be evaluated by this, so just put this fellow, that say that is k2 e to the power minus 3t, like this, okay. So this is all about that inverse Laplace transformation that you have taught right now. So we can have a different type of lot of examples of this inverse Laplace transformation. We will be going deeper to that. The other application of the Laplace, what I have told you previously, that is that differential equation solving analysis or some periodic waveform analysis. In this way we will use this inverse Laplace and Laplace many more times, mainly using the differential calculus and differential solution. So that's all for the today's class. In the next class we will move to this particular chapter of solving some waveform. It is previously given, so it is some pulse train, some periodic waveform is given. We have to solve in the form of the previous knowledge of that we have gathered in that signal systems, how to write some functions from that waveform, okay. So use Laplace on this and we will find out what is the final expression. It will be very much helpful, this concept, in the solving of RLC and RC circuit also. We will go for the next lecture very soon. Thank you very much.